Good morning, students. Today we will discuss about electrodes, electrodes and its basics. We will be concentrating basically on the electrodes which are used in the steel industry, where steel is predominantly used as the base material. Good morning, friends. Today we will discuss about electrodes. We will concentrate on the basic functionalities of electrodes, its nomenclature, and various applications associated with it. We'll basically go through the electrodes which are used with steel, being the main structural material. We will concentrate the electrodes which are used for welding steel. As you know, there are various welding processes. You can see here a manual metal arc welding. The electrode used will be a stick type electrode. It is also known as stick electrode welding. To the right you can see various types of stick electrodes like 6013, 7018, 7014, etc. Now this is another welding process which you might have seen. It is better known as gas tungsten arc welding or TIG welding, tungsten inert gas welding. Here we use another type of electrode. It is basically a tungsten electrode which is non-consumable. You can see to the right that it is basically a tungsten electrode torch, where it is dismantled with the ceramic caps as well as various diameters of tungsten electrodes which are used. Now this is another welding process known as submerged arc welding process. Here too we use a consumable electrode, but it will basically be a bare electrode spool which will be consumed and then add on to the weld which is produced. This is another welding process which is known as MIG welding. The setup which is shown here is an automated welding known as orbital welding, which we use for welding pipelines. Nevertheless, it is a metal inert gas welding or gas metal inert gas welding. Here too we use a spool of electrode wire which is fed into the weld and melts with the arc which is produced and gets added on to the weld produced. It is basically a consumable electrode. So what I meant to say with all these three slides was that based on the different welding processes, there will be different types of electrodes produced, and each of the electrodes will have various functions. Through this lecture we would try to understand what are the basic types of electrodes, what are its functions, and basics regarding the nomenclature of electrodes. Electrode types, if you talk about electrode types, there can be plenty of classifications. As I told before, some electrodes are consumable, some are non-consumable electrodes, and it will always be an interesting thing to know what are basically electrodes and what is its difference between electrodes and fiddler rods. There are type of electrodes which are solid in structure, whereas some are tubular in structure. Some electrodes are coated and some are non-coated electrodes. So each welding process will have its own peculiarities, and based on which some will use consumable, some will use coated electrodes, some will use non-consumable electrodes, some will have a tubular or a cord electrode. So we will discuss slightly more in detail in the upcoming slides. Consumable electrodes are basically those which are getting consumed in the welding process. The electrode which is shown to the left is basically a shielded metal arc or manual metal arc welding electrodes. You can see the arc will be generated from the electrode, and during the process the electrode will melt and then fuses into the weld which is produced, or fuses into the molten metal which is produced. So technically the structure of the electrode will keep on changing. Like if you have a particular length of electrode, as it is getting consumed it will naturally get reduced, as well as the electrode will naturally be melted and then forms a part of the weld which is produced. We do have another type of electrodes which are non-consumable in nature. The sole purpose of the electrodes which are non-consumable will be to generate the arc. It won't add up to the molten pool which is produced, and doesn't have additional functions like allowing functionalities or influencing the fluidity of the arc which is produced, or fluidity of the molten metal which is produced. We will come into that a bit later. Just if you can understand, there are basically two types of electrodes: consumable electrodes or non-consumable electrodes. Certain examples of consumable electrodes are those electrodes which are used in shielded metal arc welding and gas metal arc welding. And for non-consumable electrodes, we find examples in tungsten art, welding, or basically known as TIG welding. The basic difference between electrodes and filler rods, I think I have discussed this in our very first class. As the name suggests, electrode is something which permits passage of electricity. It is a part of electrodes are part of the electric circuit which forms the welding setup. So these electrodes, being part of a welding circuit, or which permits passage of electricity or current, can have polarities. It can have positive polarity, it can have negative polarity, or when the AC current is used, it permits passage of AC current. In most of the cases, electrodes are consumable, but as we have seen, electrodes can also be non-consumables, like in the case of TIG welding. The nomenclatures of the electrodes, in most of the cases, not in all cases, in most of the cases, depends on the strength of the weld which is produced. The nomenclature also depends on the type of coating which is applied on the electrode, and we'll discuss more on the strength as well as coating aspects of electrodes in the coming slides. You can see in the figure shown here the welding which is shown here is a TIG welding. You can see the welder uses a small stick. It is known as a filler rod, and he is applying the filler onto the arc which is produced. So what is basically done is he is filling the gap which is produced due to the welding with a rod, and that is basically known as a filler rod. This filler rod is not a part of the electric circuit, and hence it doesn't have any electrical connections, like it doesn't have any positive or negative terminals associated with that. In majority of the cases, we can say in almost all cases, filler rods are consumables. They will get consumed and will add on to the weld which is produced. And the nomenclatures of the filler rods are basically same as that of the base material which is used. Say for example, for welding, aluminum 5083, which is a marine grade 5 series aluminum, which is widely used for construction of aluminum ships. We use TIG welding along with filler addition of R5083. R5083 and base metal aluminum 5083 are similar. Basically, the filler material will have almost the same composition of that of the base metal which is used, so that the weld produced is homogeneous. Here we can see we have briefly discussed about tubular or solid wires. In tubular wires, you can see the core will be a solid tube. It will be a solid. It will be. It won't have a core onto that. And even if you have got any flux additions, the fluxes will be coated over the rod. But whereas in tubular electrodes, you can't see any sort of coating over the electrodes. Say for example, if you take a ballpoint pen refill, it is very similar to that of a tubular electrode, where you can see in the ballpoint pen refill the ink is kept inside the tube. Similarly, fluxes are kept inside the tube for flux core arc welding, where we have a tubular electrode. In tubular electrodes, that is the only basic difference. There are also some additional differences, like the difference in the current carrying capacity and the gases which are produced, so and so. Say for example, in the solid electrodes or the bare wire electrodes, it basically depends on the shielding from the external shielding gas which is supplied. Here we have coated electrodes. We'll discuss about the coated electrodes. As I have told before, we'll discuss much more in detail regarding the functions of the coatings, which are functions of not only the coatings but as well as the flux which is there inside the core. The basic functions of a flux are number one, it has to produce a fume or produce a shielding gas which protects the base metal which is melting. Because as I have told in my previous classes, once the temperature increases, the chemical reactions associated with that environment will naturally increase. It's not only the base metal which is exposed to a very high temperature, it is also the electrode tip, as well as the filler metal or the molten electrode which is actually moving from the electrode tip or the filler tip towards the molten pool. So we have a small area where the molten electrode or the molten filler is actually moving through the air into the molten pool. So the shielding gas which is produced due to the decomposition of the fluxes shall actually protect the molten or the high temperature surfaces, like the molten pool of the base metal, the electrode tip, the filler metal that is transferred across the arc from direct contact with atmosphere, because in atmosphere there are a lot of undesirable elements or compounds or moistures, like what you can say, like atmosphere will have lot of nitrogen can react with hot metals and produce nitrates. The basic issues with nitrates are that the structure of the nitrates, the microstructures will be pointed, which in turn will cause microstructural stress concentrations, and which in turn can result in grain boundary defects, as well as internal micro crackings, which will result in the failure of the entire weld which is produced. Because as you might have studied, any crack or any pointed cross sections are stress concentration areas, and once crack is produced, it will act as a weak point, and then the crack once produced, whether it is a small or a big, will propagate further and then will damage the entire structure. However, one thing which you have to understand is that these fumes, though it is beneficial for protecting the base metal or the protecting the molten pool or the weld pool, it shall not produce any compounds or any sort of elements which is harmful to the welder. I have discussed in my previous classes as well. Whenever we are using whenever we are welding, we normally keep a blower unit or a suction unit nearby so that the excess amount of fumes which are generated are taken out of the area or are sucked out, and the welder is exposed to bare minimum amount of fumes which are produced. And these fumes can have various sort of health impacts, like it can cause irritations to the eyes, nose, then the trachea or the respiratory tract. It can cause lung infection, whereas it can also, in certain cases, cause liver issues, then reproductive issues, so and so. The another function of floods which are used in the electrodes are, uh, the it shall have an affinity, it shall have certain elements which have more affinity towards the oxygen content, which shall have more affinity towards oxygen, so that oxides are not formed, or oxides are converted to easily removable slags. Oxides are basically impurities. Say, for example, right from the manufacturing of steels, steps are taken care to remove the oxygen content, or reduce the oxygen content to bare minimum. So during steel construction, this particular process is known as killing process. So if you might have seen, or if you might have gone through any material certificate of a steel, or test certificate of a steel, you can see elements like aluminum, manganese, silicon, etc. Or you could have easily read that these are killed steels or semi-killed steels. The basic thing is that killing means it is a removal of oxygen. Like, even if we are killed, we cannot breathe, or we cannot inhale oxygen. So you can remember in likewise, like killing means removing oxygen. So kill steels will have a very minimum content of oxygen, whereas semi-killed steels will have certain amount of oxygen. But the process of welding will take any sort of steel to a very high temperature. Like, as I have told, while performing welding, the area where the welding is performed will be taken to the melting point temperature. So accordingly, the temperature as the temperature increases, the reactivity increases, and the oxygen, or the oxides which are present in the base metal or in the vicinity, will form undesirable oxides. So it is where the function of the floods plays a role. Like, these fluxes will have elements which have more affinity towards the oxygen, and then this will react with oxides or oxygen and then form easily removable compounds which form a slag. The defects which can be produced due to the presence of oxides are like lack of fusion. The fusion may not be proper, or the oxides can get entrapped. The other is that it can cause porosities. So one of the defect, like porosities, I have shown in this slide. The other functions of the flux which is added onto the electrode is that it shall produce it shall improve the mechanical property of the well produced, and also the basic thing is that the flux addition onto the electrode shall have an alloying effect, like what is basically meant is that when a metal is getting melted, when we are welding a base metal, the base metal will be melted. The basic criteria is that the sudden change of temperature, like from room temperature to 1500 degrees Celsius or much above that, will cause a phase change. So alloying elements which are added in the flux will make sure that the desired phases are produced, and which in turn will decide the strength of the well produced, as well as its corrosion properties, etc. So the one of the basic functionality of the flux which is added is it shall increase the strength of the electrode produced by an alloying effect. It shall also be capable of producing well metal compositions, also due to addition of certain alloying elements, like the composition of the base metal shall not be very different from that of the well which is produced. They shall have a compatible composition. It can have different effects, not only in terms of mechanical properties, but also in terms of the corrosion properties. Say for example, you might have studied this um, electrochemical series. Each metal will have different types of what do you call electro potentials. So even if there is a wide change in the composition, because of the electrochemical potential, it can form a electrochemical cell and then initiate a galvanic cell and form a corrosion form, and it can result in corrosion, which is anyway undesirable. So it shall maintain a desirable well metal composition, again with addition of transferring of elements, like or alloying effect. One of the main important functions of the fluxes which are added in the electrodes are that it shall establish an arc. At the same time, it shall make sure that the arc is stable in nature. The arc shall not be erratic. If an erratic arc is produced, we cannot control the weld which is being done, because the arc will wander here and there. The basic principle is that for striking an arc, or for establishing a stable arc, certain low ionization potential elements shall be added in the electrodes. So these are basically elements of potassium compounds, etc., which basically are having very low ionization potentials. Uh, Other effect which I have already told is producing a slag. You see, slag may seem to be a undesirable thing which shall be removed, but it has a lot of functionalities associated with that. One among that is the slag produced shall be easily detachable, but also it shall also the formation of the slag, or the quality of the slag produced, will directly depend on the quality of the weld shape which is produced, because it shall ensure that the slag is easily solidified. The slag shall be easily solidified, whereas the molten pool will still be in a liquid phase. Say for example, there are many natural examples also, like in certain cases you can see only the top portion of a food is actually solid, whereas the inside portion is basically in a semi-solid state. Similarly, for example, in slag, the slag will have a slag will solidify very quickly, whereas the molten pool will still be in a liquid or semi solid state. So what is basically happening is that it will ensure that the shape of the weld produced is regular. The another main function associated with that is when a slag is produced, it acts as a shield over the base, over the weld pool which is produced, and then protect it from direct contact with the atmosphere. It serves not only that purpose, it will also ensure that the temperature gradient is not high, because when if the molten pool is exposed directly to the atmosphere, then the temperature gradient will be like 30 degrees Celsius and 1500, it will be in the range of 1500 degrees Celsius. The slag will ensure that the molten pool is not exposed to atmosphere directly, both for contamination as well as for the rapid cooling. So it will control the cooling rate, it will control the it will prevent the contamination with atmospheric contaminants. And one of the main important functions of associated with fluxes are its grain refinement. For grain refinement, many types of elements are added, like nickel is added, and then borium is added, borium, vanadium, niobium. This nickel basically is not for grain refinement, it is for austenitic stabilizing, whereas grain refinement is basically done with the help of microelements like borium, vanadium, niobium, etc. But care shall be taken so that precipitation hardening is not happening. Precipitation hardening is that if certain elements are added, those elements can react with certain elements in the base metal and then form precipitates which remain in the microstructure, and then increases the hardening, and which can make the metal brittle in nature. Last but not the least, the another function of the flux which is added is it shall aid in the fluidity of the molten metal. It shall ensure that the molten pool is slightly movable in nature. It shall not be highly viscous. So it also aids in the metal spray metal transfer, which I think you might have studied in your previous classes, and which in turn directly influences the shape of the weld which is produced. As I have told before, these consumable electrodes will have a peculiar nomenclature. These nomenclatures are basically based on the strength of the metal, weld metal which is produced, the position in which the welding can be performed, and most importantly, based on the type of coating which is applied onto the electrode. In the right you can see this is a shielded metal arc welding or manual metal arc welding electrode. Here you can see E7018, that is actually an AWS nomenclature. AWS stands for American Welding Society. E stands for electrode, whereas for filler rod we use only R. That means E for electrode, R only for R represent rod, where it is not part of the electric circuit, that I have told before. So wherever you find letter E in the consumable, it is for certain you can say that it is an electrode. Okay, and it basically contains for metal arc welding or manual metal arc welding. It basically consists of four digits after the letter E. The first two digits, in this case is 70. 70 represents the minimum tensile strength which is produced in the weld, because the electrode produces a weldment, and the weldment shall have a minimum tensile strength of 70,000 ksi. Okay, and the third digit in this case will be representing the position of the electrode position of the welding which is possible with the electrode. So 70 show the will indicate the minimum tensile strength, that is the minimum tensile strength of the weldment which is produced. The third digit, it can be either 1 0 1 2 or 4. So one, wherever you can see one, you can use in any locations, because those electrodes can be used in all positions. It can be used in horizontal, overhead, vertical, then flat, anywhere. Any type of position can be used using electrodes which is having 1 as a third digit. Whereas for 2, wherever you find 2, it can be used only for flat or horizontal positions. Whereas for 4, it is used only for flat, horizontal, vertical, down and overhead. The last digit is basically denoting the coating. This coating number in this case is 8. So 8, you can see it can vary from 0 to 8. The last digit can either be 0 or 1, 2, 3 or till 8. Um, the first two 0 and 1 will be representing cellulose electrodes. 0 will represent cellulose with sodium silicate as the binder, whereas 1 will denote cellulose electrode with potassium as binder. 2 and 3 represent rutile electrodes. Rutile is also known as titanium dioxide. So similarly, 2 will denote with sodium binder, and the 3 will denote with potassium binder. From 4 till 8, we will find basic electrodes, then low hydrogen electrodes as well as acidic electrodes. Most manual welding electrodes are divided into basically 3 categories. It can be cellulosic, it can be rutile based or basic coating electrodes. So cellulose electrodes I have told in the first two, 0 and 1. Here you can see AWS E6010. The cellulose electrodes are having a large proportion of cellulose, as the name suggests. The cellulose will be derived basically from wood flour. I will tell you why cellulose electrodes are used. The cellulose electrodes will also contain certain amount of TiO2, manganese oxide, ferromanganese, and basically it is pasted, or it is fixed onto the core wire using binders. These binders can either be sodium binder or potassium binder. Since these are derived from organic or from wood flow, it will have a high moisture content. The moisture content will be very high, like 4 to 5%. The cellulose will actually burn and form carbon dioxide, carbon monoxide, and basically this carbon dioxide and carbon monoxide will act as a gas shield and protects the molten pool, or the electrode tip, and or the transfer of molten materials. And in the weld which is produced, we can find high amount of hydrogen content in that, typically in the range of 30 to 45 ml per 100 grams of weld metal. Since these particular electrodes require some moisture in the coating, it is not baked. Baking is a process, like in many of the cases what we do is, in order to ensure a high quality of the weld, or in order to ensure that hydrogen cracking or coal cracking is not produced, we basically put the electrodes in an oven and then bake it to a predefined temperature which is specified by the manufacturer of the electrode. So in most of the cases in cellulose electrodes, the requirement of baking is not recommended, because it requires certain amount of moisture in the coating to aid certain other characteristics. The advantage of this cellulose electrodes are that these are very tolerant to site conditions, and for that reason it is basically finding wide applications in cross country line pipings. As you can see, these are well known for cellulose electrodes are well known for pipe welding. The hydrogen content is at the same time not a desirable thing, because as the hydrogen content increases, the chances for hydrogen cracking increases. So we shall have certain preheating procedures, as well as selection of steel shall be in such a manner that these are resistant to hydrogen induced cracking, or the steel itself will have low affinity towards hydrogen. um, so we will move on to the next type of electrode. These are basically root tail electrodes, which I have told here. From 2, 3, and to an extent 4 will have this root tail content in them. Root tail electrodes contain large amount of root tail. Root tail is basically titanium dioxide. About 50% of the fluxes will be root tail. However, it will also have certain amount of cellulose, limestone, silica, mica, and other elements like ferromanganese elements, and very small amount of moisture. Moisture still is high in this case, around 1 to 2% is quite high, but compared to the cellulose electrodes, it is far less. In rutile electrodes too, the binders used are either sodium or potassium silicates. Cellulose and the limestone, they will react with the arc and then decompose and forms carbon dioxide or carbon monoxide. But even in these cases, because of small amount of moisture content, the hydrogen inclusion in the weld is quite high. It is around 20 milliliters per 100 grams of weld metal. The electrodes will have a medium penetration, but you can see it will have a soft and a quite stable arc. The one thing with cellulose electrode which I forgot to mention was the arc will be very strong. Since the arc is very strong, there is a probability that the spatters which are produced will be much more. However, it is very tolerant. The cellulose electrodes are very tolerant to site conditions, so it is gaining wide acceptance. But however, in rutile electrodes, the arc which is produced is soft, and it is also stable, and at the same time, it will have very little spatter compared to cellulose. So these are basically known as welder friendly electrodes. And this electrodes will run on low open circuit voltage, but whereas in the case of cellulose electrode, I have not written here, it needs a very high open circuit voltage, like 70 volts or something like that. Technically, just for your information, welding is designed in such a way that, you see, well, in welding what is happening is that an arc is produced to generate heat. So basically it is I square R or Vi in terms of physics. The basic principle of welding is that it is a low voltage high current phenomena. This low voltage, it is designed in such a manner that the voltage requirements are low. The main reason is that in order to make it safe for humans to weld, because if the voltage is above 90 volt or in the range of 100 volt, then we will get that electric shock. But if the voltage is maintained low, then it is much safer for us to do or perform welding. So this was just an additional information which I thought when I discussed about open circuit valves. The electrodes here will also produce a dense slag, which can be easily removed, and can even form a ripple with the weld profile. And that means, I have told before itself, the profile of the weld which is produced will be influenced by the quality of the slag which is produced during welding. Here we will discuss about the hydrogen content. As I have told before, the hydrogen content produced due to the rutile electrodes are in the range of 20 milligram to 100 grams. The high hydrogen content restricts the rutile electrodes to certain mild steels which are less than 25 and also thin alloy steels with with carbon molybdenum composition or with the addition of carbon chromium molybdenum, like one chromium half molybdenum compositions, so that this cold cracking or hydrogen induced crackings are not produced. The mechanical properties which are produced due to rutile electrodes are good, and it is widely used in almost all shop floors, and it is widely used for it is known as a general purpose electrode. um, since the step of rutile electrodes also requires certain amount of moisture, baking is not recommended unless it is very damp. If it is damp, normally it is baked at around 120 degrees Celsius, but we cannot generalize that because the baking conditions are different for different manufacturers of electrodes. So what we normally do is we will refer the manufacturer data sheet, and then we will see what are the requirements of baking. So today I will wind up the lecture with this. In the next lecture I will discuss further with regards to low hydrogen electrodes, as well as electrodes which are used for gas metal arc welding. Thank you.